Our next speaker is Mathieu Ropert. As my accent's trying to suggest, he's from France. So he's a French expert who writes C++ for a living. Mathieu worked in various areas, ranging from kernel programming to web development, financial software, databases, and video games. You name it, he was there. And talking about video games, Mathieu is an expert in some historical ones. The interesting story is that one day he decided to upgrade his compiler and has been blogging about it ever since. And he shares his knowledge not only on his blog, but also on meetups and conferences, to name a few, CppCon, meeting C++ or ACCU. It is his first time on Code Dive, though. Mathieu enjoy coding, automatic stuff, photography, role-playing games, both pen and paper and live action, and video games. As befits a French guy, he likes wine too. In his presentation, Build for Everyday Performance and Why They Should Care, he will talk about build system, of course. But what's more important, he will also talk what can they do for you. And Mathieu will also give some general best practices how to keep it clean. Ladies and gentlemen, please, big round of applause for Mathieu Ropert.
Thank you. Thank you so much for coming. It's been kind of a curse of my career. Every time I come to a conference and say, hey, I'm going to talk about build system, they're like, fine, you're going to do just after the lunch break. Every time people are great, they have comfy chairs, they have a good lunch, and what's better to fall asleep than to talk about build systems? So I'm going to try to keep you awake anyway. And the good thing is, it's not a talk about build for build. It's a talk about build for everyday programmers. So I'm going to make a check in the room. Who is an everyday programmer? Who actually just writes software, not just doing build by day? OK, most of you are my audiences. The other ones, you're still my audience anyway. Although I wonder, why are you here? But don't worry, if you're really here only for the build, there will also be something for you. So when I'm asked about build, because I blog a bit about build from time to time, and when I ask programmers about build, usually I get this kind of answer. So it's like, it could be green, but most of the time it's especially complicated. It's like a Facebook status, basically. And that's the kind one. The other ones are more like, what? No, I don't want to. No, I don't want to touch it. Like, go away, go away far. Build is not for me. I'm a programmer. I don't do build. And what the thing I want to talk with you today is, what if it actually wasn't that hard? I'm not saying. Actually, I am saying we're probably making it a bit hard, and that's what we're gonna try to explore in the coming hour. So I can probably skip a lot of this. You heard it from a better presentation. Name is Mathieu. I work at Paradox. I make Europa Universalis, which is a great game you should absolutely play. Here are my contact details. If you wanna ping me, don't be afraid. I have people sending me creepy CMake lists, so you won't be the first. So what are we going to talk about it today? We're going to talk about programmers and build, and why usually they don't mix together, but maybe they should. I'm going to try to talk about modern builds. I know we use modern way too much. I use modern for lack of a better term. If you have a better suggestion, if you want to be the one who coins something better, please do it. Like, because we know this, right? Programmers are bad at naming, so whatever, you got it, modern. We'll talk a bit about tool change, package manager, modern, CMake. Yeah, this is the nitty-gritty bits that you will also explore. But most of it, we'll talk about simplicity, because again, I don't think build should be hard. I think we're making it hard. So let's talk about build together. So it's confession time, actually. I have a confession to make. I have a bunch of talks on build. I started my talking career at CppCon talking about CMake. I was also at ACCU this year talking about package management. I even have a small lightning talk that is 4 hours and 30 minutes about the Roman senator and 30 seconds about build. And I also have a blog, and the most liked post on it is about simplifying build. So yeah, it kind of looks like I'm a build engineer, but actually, I'm not. I am not a build engineer. My career has been... I left school in 2006. I have never held a job title that was build engineer. Never. Like, most of my daily work is spent programming. I make features, I fix bugs, optimize performance, you name it, code reviews. I had no idea how CMake worked 5 years ago, like none. But one day, I was like, come on, it can't be that dumb, it can't be that hard, it's software, right? We don't make software that is buggy on intention. I mean, sometimes we do, but most of the time we don't. So, yet here I am, and that's the thing I want to show, like, basically, I started all those talks because I felt like if I had to spend a couple, maybe weeks or months understanding why your build was so complicated at my work, maybe I could share some insights with you guys. And that's what I've been doing for the past couple years now. And that's the thing I'm refining yet again and again. Because, again, I think this should be something that if everybody knew a bit more about, we would have much less problems to solve, at least on that topic. And then we can focus on the other ones. So let's talk about build by making a small metaphor. As you might have heard, I live in Sweden now, working for Paradox. So now is your chance to play a small guessing game. If I say Sweden, especially it's great with international audience, what's the first thing that comes to your mind? Nice! When I rehearsed in Sweden, sorry for shouting, but when I rehearsed, nobody actually came with very name thing like meatballs or things that a Swede will know. But yeah, IKEA, of course, this is the first thing you think about when you go to. Thank you very much. I did not know this person. I did not prepare it in advance. I'm telling you, this is actually the original and first IKEA shop that is quite close to where I live now, and one of the first places I visited when I moved to Sweden. So we all know IKEA, right? Who here has never assembled any IKEA furniture? One hand? A couple hands. That's more than I would have expected. Okay, most of us have assembled at least once an IKEA furniture in our life. And that's the thing, right? You go to the shop, you see a bunch of very nice things with unpronounceable Swedish names everywhere. It looks super cool. You go to the checkout or you order online, and then you get this. And actually, it's a marvel of engineering of itself, because it comes with these things, those notices. Have you ever noticed that there is no localization issue with IKEA notices? As long as you can understand Arabic numerals and basic pictograms, and you know what a screwdriver is, you can follow it. It's great. You don't have to edit it in 10 different languages so that people understand it. But what happens if in your package you didn't get the notice? That kind of things happen. Right? Without the notice, you just have a bunch of planks and hope. And guess what? If you have a bunch of C++ sources and no build file, well, you have a bunch of C++ sources and hope. So yeah, you can call the build team and say, hey, can you make it work? Can you build my project? And, well, what if I can answer? I have no idea. Like, it's your project. You tell me how it's supposed to be built. I'm a build engineer. I'm not a software developer, right? That's not my job to make the software architecture of your project and then communicate that in a build file. That's a programmer manager. That's a programmer's job. So, yeah, without build, your software is just a bunch of loosely text files that may or may not be compiled by just sheer willpower, like GCC, start.cpp, and hope. Sometimes it works. Most of the time it doesn't. We tried to solve this, saying, OK, we don't want to touch build files, so we're going to make project without build files. Header only, no dependencies. If you ever see any of my prior talks, you may have heard that I have opinions against this, because it doesn't scale. It's nice. It looks practical on a CPP talk because people are super buy in. Like, oh, great, look, I can easily integrate this thing by copy-pasting the HTTP file in my project. And then you try to scale, and then you start looking at build times, and then you start having problems. So what I'm saying here is that instead of running away or grabbing across, you should try to embrace it and take ownership and realize it's actually not that scary. Or it could be, at least. I'm not going to say it's not scary. Some parts are very scary. Like if you start looking at CMake source, like the source of CMake, like there you'll be scared. But hopefully you won't have to do this. I've done it for you. So that's the thing, right? To reiterate again, think about it this way. Who makes the most changes to the build files in your project? If you do git log on your CMake list, is it the build engineer, if you have one, because not all companies have one? Or is it the programmers who keep adding files, removing files, changing dependencies, and all that stuff? I'm pretty sure it's clear-cut, and it's not on the build engineer side. Hence, I'm saying it's very weird that I hear people telling me I don't want to touch the build when you're actually the one making 99% of the commits to the file that actually responsible for it. So, and there's another idea, right? Build reflects the relationships between your component. It says this library depends on this library. This CPP file belongs to this library and not this library. This is a conscious decision. When you put in a source in a library, you don't do it just because you had to throw it somewhere. Well, I hope you don't. You're supposed to do it because you think, oh yeah, this thing belongs to the core component. This belongs to the database. This belongs to the UI. This belongs to whatever. There is organizing being thing. Like we are building blocks and making graphs and all that nice UML stuff that you did once in college and then forgot about. That's what you're doing when you're putting files in project in a build file. So basically, if you want to own the architecture of the software, to some extent, you have to own the build file that describes it. The good news is, build has changed. The tools have made a lot of progress in the past years. I don't want to go back. I've used Make. It was nice. I've used CMake before 2.8.12 or 3.0, basically. It was nice, but yeah, we've gone a long way now. We have modern CMake, which is just better CMake, I guess. We also have Package Manager. We also have 2 of them. We even have luxury of choice. Like, I don't know, you asked me 3 years ago, and we said like, I have no idea. But now we have 2. We have 2 good ones, and they're both doing the job. We have it's a great time to start looking at build. And actually, the good news is that a modern build is much simpler to maintain because, as we will see, by splitting a bunch of concerns, we make it much simpler to understand. It will also help you because when I asked around a couple of times when I prepared this talk and other talks, the question I like to ask is, why are you not using the latest compiler? Why are you not using the latest library? Why are you not using third-party libraries at all? And half the time the answer, maybe not half the time, but a lot of time the answer I get is, oh, the build system. Like, I cannot update the dependency. It's going to cost me like a billion years in tweaking the way we install them and all that stuff. Or I cannot upgrade the compiler because, yeah, same thing. It requires me to tweak the build files. I don't want to touch this. I've heard that a lot. And usually the 2 are intertwined. Because when you want to upgrade a compiler, sometimes you find a bug in a third-party library, so you also need to upgrade your dependencies, and then it just blows out of any budget you would possibly get. The thing is, I want to have a lot of time to talk to actual proper transition in this talk, but I've talked to some people that have used drastic solution to transition their build. And when I say drastic, it's literally set the old one on fire and make a new one. And by just running a program that just looked at the header files and the inclusions, rebuilt the dependency graph, and from that just made a simple CMake file. And it was like, done. You can throw the whole thing away. Okay. So I talked about like principles and ideas, but I guess you want something concrete now. So let's see a bit of the anatomy of the build. Like how exactly is it supposed to work today, or how I would see it, at least. You don't take it from me. You can also like have other opinions. But here's the thing. Basically, what you do first, you install your dependencies, right? Because more and more you depend on stuff. I mean, unless you rewrite everything yourself, which is kind of noble, but also weird. I mean, I don't know. I'm not an expert. I can't rewrite OpenSSL and OpenGL in 2 days. And every time someone tells me he can, I can tell you he's wrong. Then you run some configure step that is supposed to make sure that everything is there. Do I have std.io.h? Well, at least CMake doesn't do that anymore, but you know what I mean, like checking that everything is sane. And then you actually build the damn thing once you're done. And usually the first 2 steps, you do it like once in a while. The last step, you rerun it every time you actually need to rebuild your project. Because you don't install dependencies every day. You may or may not be adding and moving files away every day. So who does that? That's the thing. Usually the problem is, those are 3 different jobs. A lot of builds I see do the 3 jobs at once in one thing that is supposed to be only one of them. And that gets messy because you're basically using a tool that is not made for it. So the idea is that the install of dependencies obviously should be done by a package manager. The configure step should be done by a build generator, which is what CMake does. And then your actual build, well, you run your build tool, right? So your IDE behind the scenes, or Make, or MS Build, or Ninja, or one of those. The question is, how do you split those concerns? Basically, you do it by splitting a bit the input sources. What do you need to? What does a package manager need to install your dependencies? Well, it needs a list of the dependencies you want to install, obviously. And that's one thing, right? You have to tell it, okay, I need OpenSSL, I need Boost, I need a bunch of stuff. But that's not enough. Because if you tell a package manager to install a bunch of stuff for your computer, maybe it will happen to do it. And then what happens? It doesn't link with your project because it's using another ABI, or it's linked against the static runtime and you want the dynamic runtime, or it's using a compiler and you're actually using this other compiler. There's a lot of reasons why it could go wrong. So you actually have to tell it, what is my tool chain? What is the sets of flags and compilers I'm using to build this project? So you use toolchain config. Don't worry about it. If you're scared about those things and you have never done one in your life, I get back to them in the later slides. Once you have that, you can install the dependencies. That's great. And now you want to configure. Obviously, you need a build file for that, like CMake list, something like that. You also need a bunch of sources, right? Because, I mean, CMake is not going to do a lot of stuff with your C++ source. People think it does a lot. It doesn't. Mostly what it does is checking that if you say, this CPP file is used in my project, it's going to check that the file actually exists. That's just about what it's going to do. It's probably not even going to parse it or open it. Just say, okay, it's there, so I guess I have everything I need to build. It's really sanity check. Can we continue or not? And again, since you're going to build, it's also going to need your toolchain again, because he's going to want to make sure that the compiler you use for your dependencies is the same one as you want to use for your project. Because if you don't do that, you have surprises. And then building is basically taking what configure generated, taking your sources, and then just invoking CC and LD and all that stuff. Let's go back to those components one by one, real quick, and then we can delve in. So, broadly speaking, the job of the package manager is fetching all the dependencies you need to build and ensuring that those binaries are compatible with the compiler you're using with your toolchain, basically. It could be by either rebuilding everything for your toolchain, or it could be simply by finding a package that is binary compatible using some rules that you define or that it has. Your build generator is basically what you run when you do CMake. CMake is actually not a build system, it's a build generator. I know it's a very pedantic definition, but there's actually some reasons why it's called one and not the other. So basically, a build generator just say, okay, you want to build this project, do I have everything I need? You're basically like, you're opening your IKEA manual, and there is a list of all the things at the top. Like, okay, you will need like, just check that you have like 5 screws, a screwdriver, a bunch of planks, and a friend, because it's better with friends to mount IKEA furniture. You can trust me on this. So it checks all that stuff, and if everything is missing, it shouts, stop. Do not try to mount this furniture alone, or do not try to mount it without the screws, and you're just gonna fail. Just stop here, get what you need, come back and retry. And if everything is there, then it can actually write your make files or your Ninja files or your VCproj or your whatever Apple uses. I don't know, I'm supposed to support Apple, I hate it. And your build tool is basically just the actual script that is just gonna run your make commands and try to also make sure that if something hasn't changed, it doesn't need to rerun it again to save you time. And has been doing that for a long time, and we love it for it. And of course, it should also restart the whole process if if one of the inputs have changed. Like for example, if you change the CMake list, it should rerun CMake. If you have changed the list of dependencies, it should also rerun the package manager to install what's different. So if you look at the workflow in the end, I don't know what you use today, but I assume that most of you are just like running CMake or an equivalent. Who doesn't use CMake here? Or actually, most of you are using CMake, more than I thought. Okay, right. So I'm on point, I guess. Okay, so I guess today what you do is that you run CMake -g blah blah blah, the name of the generator you want, and then you just run make or Ninja or you open your IDE. What you do with what I would suggest you do with the modern way is just exactly the same thing, except before that you will have a first step that runs a Conan or VC package or whatever package manager you pick. I'm saying those two because that's basically the two that I know that work well. We'll probably get something more in the future. I don't know. I can't tell the future. Then you run CMake. There is some magic that you have to add on top of what you do today, but it's not very complicated and it has to do with the toolchain and the package manager. We'll get back to that. And then you run make. And as you can see, it's kind of the same thing. Like, I don't see a lot of difference here, and I think that's for the best, right? We're not breaking everything. We're just making things simpler by adding 1 or 2 more steps. And that's the beauty of it. So let's talk about toolchains. Who here has heard about toolchains? Good deal of the audience. Who uses them? Half of the one who actually knew about them, who was already like a third of the room. Interesting. So what's a toolchain? Okay, let's explain it by an example. So let's say you have a CMake list. I did not make this up. It's basically how it looks like in one of the projects I maintain, and I've seen this a lot, right? I don't know. Like, does it sound something you would do? You describe your project, and then you have a bunch of, am I on Windows? Please set those compile flags. Oh, I'm on Linux. Please set the compile flag. Oh, I'm on Linux, but this version, set only those flags. Yeah, I see a bunch of people. Yeah, I do, yeah. So what happens the day you have a dependency? Like, you have, I don't know, OpenSSL. I keep using it, but let's say curl. Let's talk about another one. Okay, let's say you have curl, and it's like, okay, but how do I use the same compile flag in curl? So, I mean, you don't own curl, right? So how do you take this and move it here? So obviously you could do as I've seen some people do. You just copy paste it in curl build file and you just fork everything with dash the name of your company. Or you can use some kind of interesting mechanics inside CMake to refeed those flags into a sub-process you invoke the reconfigure. I've seen it too. And I've seen a lot of people inventing a lot of things. What you're doing here is reinventing package management and tool chains, but harder. Because if you look at this from a programming perspective, I think it would be much more obvious. It's like, oh, it's a dependency elevation problem. It's something that if I have a same thing that is shared by 2 components, well, obviously it should just go up. And that's the idea of toolchain. It's as simple as that. Is you take a text file, you put all your specific compiler stuff in it, and then you feed that file to everyone that has to use the same things, and you're done. And you know what? Since it's a file, and technically you specify into your build system which one you use, you don't even have to have those ugly ifs everywhere. You can just say, you know what? I have one for Windows, I have one for Linux, and I can have one for every target. And each one of them is just a definition. Where is your compiler and what's your build files, your build flags? And you can just switch depending on what you're configuring for. Just as simple as that. So yeah, inside, basically the idea is you abstract away. You abstract away stuff that should not be in the build system because it does not actually depend on your project. It depends, all the things that you build together needs the same one. So obviously it should not be owned by one of those. It should be shared by all of those. So you abstract that away in a file. And since then it's abstracted away, it's much easier to propagate to dependencies because they all have to point to the same thing and then they're done. And if you ever done cross-compilation, it should probably sound more obvious because I'm pretty sure in cross-compilation that has been the default for a long time. And actually, even if you open CMake documentation for some weird reason, the first thing you say is, oh yeah, you want to do cross-compilation, let me tell you about toolchain. Like, why don't you just say that as a default? For some reason they don't. I kind of want to challenge that. Because, yeah, basically you define which compiler you want to use, you set the common build flags, like architecture, optimization, debug, whatever you want, and then you're done. And that's everything you do. In a toolchain file, you may describe one or more targets. The reason is, I think basically the reason is IDEs. Because a lot of IDEs have this great option on top that says, what build profile am I using, and then you can select it. Like if you use Visual Studio, you know that debug release really well with Debian or something that is on top, and that you use to switch from debug to release. By default, toolchain comes, I think, more from the Unix world, so there are more of the idea that every build should have its own build directory and its own build files. Windows is taking another approach. Both can work, so usually what you do is that for make targets, you just do one per toolchain and one per setting. And if you're on Windows, you do one per toolchain, but then you do sub-variants for debug and release. It's doable. That's why you have stuff like generator expressions in CMake. I'm not going to talk about generator expressions today, but that's how you do it in CMake. It's not that ugly. So how does that work? Well, basically, instead of just running CMake -g, you had -d CMake toolchain file to CMake, and CMake will just preprocess that file for you before it runs the configure thing. And that's done. And the content of that actual toolchain is just a bunch of sets, almost as if you would have put it if you were doing it manually. There's no magic involved. If you're using VC package, which we will come to in the next section, there is a define that you pass to CMake when you use it with VC package, which is, oh, VC package, when you load your own thing, also load my definition file. If you use Conan, it's a bit different, and we'll see that in a minute or two. Because Conan actually is not built around CMake. VC package is built around CMake. Any package that is not CMake, they repackage it as CMake. That's their technology of choice for handling the problem of different builds. On the other hand, Conan has decided that they should be able to build whatever build system you use. So instead of making you write in CMake, they do no. Write your toolchain in a language agnostic, like YAML file or something similar, and then I can translate it to whatever build system you want. I think it's a cleaner approach, but since we don't have a de facto standard for toolchain profiles, I think it could be a candidate, but we're not there yet, sadly. So basically, when you have to think, where are the settings, the compiler settings of my project? In the toolchain file, you put the linker, the assembler, the compiler, basically every code generator you have to use. You put the architecture flags, the ABI flags, everything that can break binary compatibility or affect it should be there. You also put optimization and debug, because usually they're part of your build profile, and you usually don't do that. What do you put in project? Well, the thing that you change per project, and that's usually warnings. That might come as a surprise for some of you. But the reason I suggest you don't put warnings in the toolchain file is that you will build dependencies that you don't control. And if you put -w4, -w error, you might spend a lot of time fixing their warnings, which is probably great for the maintainers if you push it back, but it's going to cost you a lot. And there are also some core Windows library that do not compile with all warnings involved, so you probably want to be able to tune them down if needed in your project. That's why I suggest you put it in your project. Your project is responsible for how strict you want to be, but each project has its own rules, and it's very hard to enforce your rules on somebody else. Sometimes you have to, when you include them, but I've seen people just brag off when they include stuff like that. It's not great, but it's understandable. Package managers, which is the other big thing that is not seen in many builds, I think, today and should. How does that work? How do you install a package? When you think about it, it's super simple and it's nothing new. Who here has ever used, I don't know, emerge? Or keep your hands up, or apt-get? Yeah, you use the package manager once in your life, right? It's every Linux distro in the world has it. I'm pretty sure whatever Mac has is also I can't remember the name, but it also is the same ID. Basically, you want to install a package, it's just, okay, you install the dependencies of said package, then you download the sources, you patch them, possibly, you configure your build, and then you put that in some install directory, and in the good old days, you would put that in a tar zip, and then you would burn it on a CD, and that became a Linux distribution. Today, we do that online because we have the internet and all that stuff, but that's basically the same idea. It's been there forever. If it's a binary, it's basically the same thing, except you don't have to patch and you don't have to compile. You just download some binaries, and then you're done. So yeah, the job of a package manager is to install recursively all the dependencies you need and make them available for the build system, which basically means generate a small manifest that you can feed into the build system, and then when you do find package or locate dependency or whatever is your intrinsic key to request something, it can just find it. And additionally and optionally, it also can make your own project available to others, because I mean, not all of us are developing actual executables. Some of us are making libraries, frameworks, and you probably want your consumer to be able to use them as packages. That's just going to simplify their lives. The way it works is actually pretty simple. Like, let's say we have our great workflow from the last time, and you want to install two dependencies, number 1 and number 2. Well, we just recurse the process. For dep 1, we install the deps, we configure, we build. For dep 2, we do the exact same thing. And if dep 1 happens to also have a dependency, well, we just recurse one more, and then I don't have enough space on my slides to continue, but you get the idea. It's basically just the magic is there. You just repeat the same process over and over again, and it just, recursion is the base of a lot of problem solving, and it turns out it works very well here. Now, you might wonder, okay, there are two package managers. He keeps talking about this Conan thing, this VC package thing. I have a whole talk about what we have today. I will try to summarize it a bit here. There are two big competitors today on the market for C++, Conan and VC package. Conan started like 6 months before. VC package actually considered using Conan when they started, but they, for different reasons, they decided not to. They don't have the same focus. Conan is really business focused. The idea is that you are a business, you're a corporation, you have code inside, you need to handle third parties, it's a pain in the ass. You want to be able to install external dependencies for your project. You might want to be able to share and reuse the binaries. You maybe want to audit them. You probably want to fork a repo that is external and possibly fork a version of a package because you have a critical bug you need to fix and you cannot wait for another release. Or, I mean, we all have our problems. Or even then, maybe you are so big that actually you publish packages that the only other users are also people from your company. Because you're so big that you have like guys making a framework and it's actually a version framework and different application in your company use different version of the framework. So yeah, obviously I think Conan is probably targeting more those use cases. It's like you can set up your own repo, you can change your own repo, and since it's acquired by JFrog, you have Bean Tray or Artifactory, a bunch of other stuff that probably make build engineers very happy. You have all that stuff out of the box. A VC package comes from another direction. VC package comes from Microsoft being like, oops, people are using C++ less and less because it's super painful to use dependencies, and no new student in the world wants to do something that only has console. They want graphics, they want sound, they want network, the internet, all that stuff that is super new in '98 but not so much today. And why is this super language that everybody hears about has none of this? We might have networking at some point, but it's still not there. And don't get me started on graphics. So yeah, you need third parties. And basically the thing VC package wanted to solve is like, I start a new project, I want to be quickly able to use Boost or, I don't know, like ASIO, Beast, OpenGL, DirectX, I don't know, whatever. Like, you want to be able to do that. So they focused a lot on that. And basically, they have a lot of package libraries. Much of their effort today has been in packaging libraries, and the tool has evolved when there was one library that they could not package because of some special case they could not handle in the packager. They're coming from another approach. So depending on your use case, you may or may not find one more amenable to you than the others. On the other hand, if you want to use it for your company, it's a bit harder because it's not as easy. I think they will target it at some point and try to sell it to you, but I don't think they're there yet. But they're evolving fast. Both of them are actually evolving quite fast. If you want an idea of how it works, that's probably not going to be a good discriminant because on Conan, you're just going to go into your build directory, go Conan install ... and then do cmake ... and pass like the path to a file that's Conan has generated, and then you're done. CMake will find all the thing that Conan installed. And if you do VC package, you will do VC package install, the name of the package, and then you will do cmake blah blah blah, and then you will say cmake use VC package root cmake file, and you will find all the package there that Visual Studio VC package has installed. So it's quite similar. There is some difference in philosophy. Conan will make the packages local with a possibility of having a shared local, repo on the machine. Visual Studio will share it per user by default, and then you can tweak around. And it's just details at this point. So VC package, since it's based on the command line for installing different things, you may have to just make a text file and just do like a pipe xargs VC package, and it will just run for every package in the thing. It's not too bad. Not as out of the box, but doable. Conan, on the other hand, will ask you to write a file in a specific format to describe what your dependencies are. You have two choices for that. One of them is a simple text file, one per line, you say which package you want. The second one is a Python script, so you can have a bit more logic in it. And the power of it is that the content file PI thing that you write is actually a package manifest, meaning your project becomes a package and you can immediately publish it on Conan and reuse it from other Conan projects. So you get that out of the box. A VC package is really made for you to use third parties and not the other way around. So if you want to package your own stuff, it's not impossible, but it's not as out of the box. It's a bit more tricky. So I would say, to recap what I said in another talk, if you want to try out something real quick, it's like, okay, I want to check out this new third party, see if it works, how it works, play with it. VC package, install name of the third party. You invoke CMake with dash VC package .cmake and you're done. It will find it. It will launch it for you. That's literally the use case we wanted to solve. So if you're doing personal projects, if you're doing education, again, the big problem of education today in C++ is that people are like, oh, it's super hard to sell C++ because it's so damn console and nothing. And that's how you solve it. You just give them you use VC package install and you get like a network library or a graphic library and you can have fun. As long as it's not cute. Sorry, I just saw Hansel in the first row. If you want to go like corporate, if you're big, or if you aim to go big, if you want to have your own repo, if you want to fork some repo, if you want to do all that things that people do with repositories and all more craziness, Conan will probably give you more stuff because that's their main focus today. So now we come back to the build files because I realize now I've been talking for like, what, 25 minutes? Maybe 30 minutes, and we still haven't seen any build file. We've seen a bunch of tools and a command line invoking CMake. So actually, that's a big question that I think about it. Like, in the third chapter, I think, I renamed all my chapters just before this, so I'm confused about the numbers. But 2 chapters ago, we used tool chains, and with tool chain, we just say, okay, every build flag has nothing to do in the CMake list, we'll just kick it out. Okay, cool. And now we're making package management. Any ugly scripting that's trying to run sub-processes to install some stuff, we just kick it out too. It's the package manager, this problem. So what do we have now? Not much, I guess. Actually, that's the whole point, and that's why I think build can be simple. Once you have a package manager whose responsibility is to handle your dependency, and a toolchain file whose job is to describe your build environment, well, what kind of weird things are you going to put in a build file? I'm curious, tell me your stories, because most of the time there's not going to be. You're going to say, oh, this is a library. This is the source file of this library. Hey, this is another library. It depends on the previous library. Hey, it's an executable. It needs both. Done. Or maybe you have test. You should have test. But yeah, most of the content is really describe the dependency graph for your application in terms of sources, and that's about it. So basically, yeah, you define libraries and executable. You define dependencies between them. You define test. Again, do test, right? And then you're done. So if you want to talk CMake macros, because I haven't seen any CMake yet, so I don't know if you came for CMake. Here's some CMake. So you would have a CMake minimum required because you need it at top. If you don't use it, it will make one for you, and you will probably not be the one you want. Please use 3.10 or something super recent. They have a bunch of funny new features in it. You do project because you need to define a project. And then you do find package because you're trying to find the dependencies you want. Use required, please, because the idea is that if the package is not found, you should not continue. Enable testing. You want to test. It's great. And then you add library. So you say add library, and then add executable, add test. Classic commands. I hope nobody's too scared about this for now. If you ever use CMake in your life, you probably saw this. I hope you did. Then you start to do advanced modern CMake, as I called it like 2 or 3 years ago. I hope now it's not as modern and new anymore. You but just say like, okay, this target needs those include directories. This target needs those definitions. This target actually depends on those targets. They should really rename link the libraries into add dependency or something. I hope they will. I suggested it a couple times, but take times. And that's it. For extra best practices, check and fail. A huge issue I encounter when I try to package others' code, but also sometimes in my own code, but the most common that package manager will find is that people do not like when their build fail, and they don't like when the build environment doesn't work the way they were expected. So instead of saying, hey, user, you gave me something I can't work with, they try to save them and fix it. Anyone here has ever used Google Test? Anyone here has ever tried to build Google Test on Windows? How many had fun with the fact that Google Test changed the runtime library and you feed it? It's great. It actually, there is a in Visual Studio, in the CMake list of Google Test, I think they fixed it now. I told them a couple of times ago. They say, oh, are you on Windows? Yes. Are you using MSVC? Yes. Are you using /md? Yes. No, you're not. You're using /mt now. What? I told you this is my runtime. I don't care. You're using /md now. I think they added a flag to turn it off. Yeah, whatever. So basically, the thing is, do not try to fix the build environment. Tell people your build environment does not work for me. Because again, you're not alone anymore, right? This is the idea. We're moving toward package management. Your one package in a nice recursive graph of packages being built. If you start locally to try fixing problem, you probably create problems for people down the line. Another big case, I have a fuller talk about this, but another bigger case that I want to warn you against, trying to install dependency when missing. I think the biggest culprit I ever heard about is, I can't remember, the Python thing that Google does for math and stuff, whatever. But yeah, if they detect a missing library, they just install some sources for you and then they build them and then they link them. And then it's great because you realize when you link that you have two versions of curl. Because you fed one to the program, it did not find it for some reason, then it installed another one. It's great. No, it's not great. It's because those kinds of errors are terrible to debug, terrible to fix. So yeah, just tell people I can't work with this, and then they will just fix it. That's how it should work. You can have warning flags. It's fine. It should probably be in your project file, but do not try to override any other flag. So compiler flags is one big, like most compile flag is a big no. Don't change the runtime because you don't like it. I mean, I don't like some runtimes too. I mean, I work on Solaris. I didn't like a lot of things. But no, you should not do that because the other one will still link with whatever you say. So it will just get like mangled name, blah, 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 does not match. Not fun. Or worse. It will actually compile because you're linking both runtime and they have different mangling. And then when they try to talk to each other, it's interesting to debug. Yeah, like all the ABI problems are very fun to debug, especially if they don't generate errors. So please generate errors. And basically, yes, if you see a script construct inside a CMake list, it's not 100% sure, but there is a huge chance you're trying to solve a problem that is probably a package management problem or a toolchain problem, and that you could simply abstract away by having something outside that you just fit in, instead of starting to do for or macro functions, all of that stuff. And we're closing to the end, actually. So let's try to recap real quick what we saw today. So the first thing I want you to take home is really that the project build should be a maintainer concern. You cannot just cop out and say it's a build problem. I just make software, I don't make build. Because again, your software without a build file is an IKEA furniture part without the notice. And no, that doesn't work like that. The guy who designs the planks is the guy who designs the notice, or it doesn't work. It doesn't have to be hard. Build can be simple. It's just that usually the wrong level of abstraction wasn't used because we didn't have package manager, because we didn't think about toolchain. There's a bunch of reasons, but now they're there. And now we can basically make things much more simple because we just split the concerns where it works. It's not new, right? It's what we've done in computer science forever. And that's why every time we have something that hits a roadblock, it's probably because we need to take a step back and say, I know, another layer of abstraction. It's kind of becoming a meme, but sometimes actually the right solution. And yes, keep your CMake list dumb. Because there is a huge thing I usually heard when I talk about CMake to people. Like, oh, but really, why do I have to use CMake? It's terrible. I heard about this new great thing that 2 people are using. It's apparently awesome. I see some people laughing, but yeah, I mean, it's probably true. They're probably awesome. CMake is bad in a very, very great numbers of ways. There's also, it's doing something very good, which it made everybody use it. And that is very valuable. Because again, why VC package work is that most packages work with CMake. So we can just install one build tool and then you can compile everything. Conan, on the other way, has to install every crazy build system in the world to package them. And I can tell you, sometimes you pull your hair off, especially when you start running configure scripts on Windows. Have you ever tried to build up an SSL on Windows? It's fun. No, it's not. Please don't do it. Oh, just use CMake. Right, but the day we have something better, because hopefully someday we will somehow all agree that another one is the next best thing and we should absolutely be using it. I can't tell you which one it is, because if I knew, we will already be using it. But the day we do that, you know what? A CMake list that is just a definition, a list of projects with a bunch of the declaration of dependencies, I'm pretty sure it takes me like 2 hours to write a Python or Perl or whatever regex script to just parse it and output it in another format. It's almost descriptive at this point. So it doesn't really matter which language it is, as long as it's easy to digest. So there we go. If you want to know more, because basically I only had like a bit less than an hour, especially for questions and all that. So when I wrote this talk, I discovered that it was actually 3 talks, and more exactly, it was more an introduction of other talks that I made. Well, 2 I made, and 1 that will actually be made one day. So the first one is the CMake modular design. If you have seen it, you might have seen some similarities that I did 2 years ago. There is 2 versions. I think the second version at being C++ is some revision I made, but the original one has a better video quality, so go with whatever you prefer. Package management and how it is today. Well, it's not today anymore, it's 6 months ago, but it's still close. I've done it for ACCU in April, so it's online, it's pretty close. It's still pretty relevant, and you should get everything about the package manager part. Tool chains, I have this talk ID, C-Sign wrote this one, that it should happen. I've submitted it at a couple talks. It might happen next year. It's not there yet, but it probably will be. And then I will have more details about the nitty-gritty bit of how exactly you set up your tool chain, like line by line in CMake and other great stuff we all want to hear, I'm pretty sure. Oh, and furthermore, I think your build should be destroyed. Thank you. And now we can take questions.
Yes. Do you hear me? Yeah, I think you do. So the same rule follows. If you have a question, please come a little bit closer. I have a mic to handle, and let's make some cue. Great. I made it on, I think.
You killed the mic.
I have 2 questions.
Go ahead.
One about simplicity of CMake's list. I agree totally. 2 things which we have in CMake list are copying files, not source files.
Oh, like install.
Artifacts for Unity, for example.
Right.
About this.
Okay, so I have the pleasure or displeasure, I don't know how you put it, of not working with Unity. But unit test, right. Right. Because there is an install step that is actually baked in CMake. When every time you declare a project, you can also declare some okay, how like make install is not something new either, right? It's the same ID, and CMake has a support for make install, but I'm not sure it runs before your unit test. I guess a bigger question is why you need to copy stuff if your unit tests are going to use them. Like, isn't there a way you can fit those into your unit test without copying them? Like, just passing some argument saying, hey, here is the files you look at.
We copy this to build a directory to have relative paths, for example. So this is one part. Okay, yeah. We can agree or not, whatever. And second part, for example, we use protobufs to generate
code generators.
Yeah.
Yes, I deliberately skipped code generators from this talk because I only had an hour. If you were at CppCon, there was a talk from Google actually talking about protobufs and the fact that code generator are like the heavyweight of abstraction and how. So yeah, I mean it's a cop-out to say please don't use them. I know sometimes you do. I know they're hard. We can talk about this later. It's almost a talk of its own, how to cleanly use a code generator with CMake. It's not impossible, There are some options, but yeah, code generators are painful, and I encourage all of you to think twice when you think, oh, I can easily solve that with a code generator. Because I've been at several companies, and all of them at one point of their life said, oh, I know, I will solve it with a homemade code generator. That's gonna be fine. And then you look at, hey, someone has to maintain it, and then everybody leaves the room, like shouting, like, nope, I'm gonna use my senior privilege to be sure that I will not be put on this project. So yeah.
Okay, so you discourage this?
I discourage code generator in general, yes, because I know they can solve a very good problem, but I think they're overused and they have to be maintained, and they usually come in the form of a quick Python script that you will never need to maintain again.
Okay. So
until they break.
Yeah. So the second question, because I didn't catch it properly, I used the VC package
Yes.
manager. And this toolchain, you said that in our CMake lists, we only, for example, should store warnings, but there's this toolchain will be shared between package manager also.
Yes.
So, for example, flags for code coverage, I don't want to coverage dependencies, but my code. So how about this problem?
Code coverage, it's a good question. Anything that doesn't break the binary interface, you don't need to. If you can link together, you can probably override them in your only on your project. This is the tricky part that needs a bit more like again a full toolchain talk. Is, for example, when you want to build your project in debug, but still want your dependencies in release because you don't care about them, you know you're not going to debug them. You just want them binary compatible. So you just want to override like optimization flag locally or stuff like that. It's not impossible. It takes a bit more machinery, and I think tool chains are slowly getting there. That might still be requiring some acts locally in your CMake list, sadly. But I think that this is going to be much less. So
Okay.
that would be a first step until we can get something a bit more working on this. This is a topic I'm exploring like on the sides. I know it's still fresh, but hopefully we will catch up.
Okay, so thank you.
Okay. Who has a question to Mathieu? Please come, don't be shy.
I don't bite.
Yep. Please come closer.
Come into the light.
Come over there. All right, so have you used the fetch content module of CMake?
No.
No. Okay,
No.
that's
I know it. And I
that's
hate it.
embarrassing for me because I wanted to ask you for your opinion about this. Could this
Oh,
be,
yeah, okay. Fetch content breaks the encapsulation model of package management because it means that your package is going to install and use dependencies that nobody else can know about, including the package manager. And something I didn't have the time to tell here, but a huge problem in package management every time you start to scale it more than 2 packages is the diamond issue, which is you have 2 dependencies, both of them use the same library, you have to make sure they use the same one, or it's completely broken. The only way you can reason about it is at the package manager level, because it can see the whole dependency graph. The problem of fetch contents, it hides half the dependency graph of some of the packages. So you can't reason about it, and then you end up with fetch content downloading another version of gtest with another profile build, and then you don't know about it, and when you link, it just, if you're lucky, it blows up in your face. If you're unlucky, it blows up in your face when you run, and it's much more fun.
So the conclusion is it cannot really be a substitution for real.
I think it's a bad solution to an existing problem. Package manager is the actual solution.
Thank you.
Okay. Anyone else? It's the last chance.
You'll never see me again after. What?
I think we will see Mathieu anyway as well on the middle party, and today after the lecture. So if you'd like to talk with Mathieu more privately, I think with the Q&A session we can finish a little bit earlier, and we will meet at 3:30. On this stage there will be Mateusz Pusz with the lecture Rethinking C++ templates. And for some of you, there was on the agenda on the stage number 8. There will be a change because there will be extra lecture from Björn Faller. And to be more precise, I have it on my phone.
It's his talk about dry.
Yeah, something about dry, but just to be sure what needs to be dry. It's about modern techniques for keeping your code dry, so to be precise. So that will be stage 8. Stage 7 here at 3:30 it will be Mateusz push. So thank you very much for coming, and big applause for Mathieu.
Thank you.